Okay, I've given the that main circuit board a good rinse in the sink, and I've just remembered that really we probably could do with having a look at these little infrared transmit and receive modules. I'm just having a look at this one, and they are labelled up. This is the left channel, and this one looks okay, so I don't think we need to disassemble that one. But looking at the right channel, I can definitely see some corrosion. It's not particularly severe, but it's actually encapsulated in a little can, and we can't really see what's going on inside this can. So I don't know if that's just going to focus. Maybe not. Okay. Well, there is some corrosion that I can see evident, so I think we could probably do with just removing this can and just having a look inside, just making sure that it isn't too bad and there's nothing grossly shorted out. I'm assuming that well, let's have a look at a couple of parts on it. I can see that there's a little LED on the board here, which is going to be an infrared transmitter. And there's also this little photo diode here, which is a receiver. Because the interesting thing about this Bang and Olufsen remote control unit, and one of the things when you look at the advertising, it makes a big point of saying that this unit transmits and receives information to and from the hi-fi. So as you say, you would transmit the information using this infrared LED, and then in any communication information such as volume settings and things would be received back by this photo diode here. And as I said, it's encapsulated in a little steel can, so I think we just really need to just install this little steel can, if we can, just have a look underneath it, making sure there's not too much damage or no damage going on unforeseen. Right, I suspect that this can is going to work as a massive heat sink, and probably going to end up burning my hand, which will be a laugh, no doubt. See if I can flow some more solder onto this joint. Oh, actually that came off much easier than I thought it would. Yeah, that doesn't actually look too bad. Actually, there is some corrosion inside the can, some battery electrolyte residue. So we will remove that. You can just see that also pressed up against the inside of the circuit board, there was just a little piece of cardboard. It feels like a bit of wax cardboard. This is obviously just some form of insulator so that the screening can doesn't short out. I'm kind of wondering why it had this screening can round it, because this won't be particularly high frequency. So I wonder why they bothered to screen it. Yeah, don't know. Interesting. Okay, we'll just give that a little bit of a clean with IPA and then we'll wash it off in the sink as we did with the other one. While I was downstairs at the sink, I was actually having a think about what had actually happened to this, and I think I can see the chain of events. Now, as I said, I've actually been given this unit to repair by one of my work colleagues called Richard. Now, thinking back, Richard is a really big fan of a certain brand of music called Northern Soul. Now, I don't know if anybody have ever come across Northern Soul. Northern Soul is a little bit like music, but crap. And I suspect that what's actually happened here is that the batteries inside this remote control unit, what they've done is they've actually sacrificed their guts. They've spilled the guts all over the circuit board. in order to actually save the unit from having to play some Northern Soul music. So I think that's probably most likely what happened here. And yeah, I'm actually wondering whether or not I should actually be repairing it, because I really don't think we need any more Northern Soul music in the world. I can feel as I wash this down with IPA that the board's a little bit sticky, so that leads me to think that this board has actually got some conformal coating on it, which is kind of interesting for a domestic indoor product. Normally you would put some varnish on a circuit board if it was going outside or something, but this product was only ever designed to go inside, and yet they've still bothered to conformally coat anything. Again, I think it just goes to show the quality of this Bang and Olufsen product. And again, if anybody's got any experience of other Bang & Olufsen products, maybe, I assume they're still building equipment now, Bang & Olufsen. I think I've seen them still in the shops. I'd love to know, is the modern Bang & Olufsen equipment, is it as good as the old stuff? Or is it just cheaply manufactured junk now? But certainly this thing just exudes quality, in my opinion. It really is just quality. And that's one of the reasons that I think that working on old equipment like this, it is a pleasure to work on. I know that a lot of people do repair all the modern surface mount devices, and people can repair iPhones and all that kind of thing, but I certainly don't have the skill to do that. This really is about my level, kind of discrete transistor and IC technology. Modern devices are just so incredibly complex. Hats off to any of you guys who can do that type of repair. As I say, it's well beyond me. Okay, that looks. I was going to say that looks okay. I can just see a little bit more corrosion we need to scrub away there. Okay, I'm hoping you can see that. We've scrubbed off most of the corrosion now, just leaving the board clean. And what we'll do is, I'll just take it downstairs and we'll give it a wash in the sink and let it dry for the weekend. Okay, it's a couple of days later, and this has been drying next to the radiator, and yeah, it all seems pretty dry. I think before I do anything else, I'm going to replace this capacitor that's burst open, which is this one here. Let's just see if I can get it in camera. Okay, you can see that there's a load of black gunge sticking out at this end here. Well, that shouldn't be there. This capacitor should look like this one. So this is like a rubber plug that's been just effectively blown out. This capacitor has gassed inside internally, and the pressure is increased, and that's blown the rubber bung out. So there's definitely not something right with this component. So what we will do is we'll take that out first. Okay, the value of this capacitor, just reading it, it's 47 microfarads at 10 volts. Let's just see if I can bring you in a little bit closer. Is that going to focus? There we go. Hopefully you can see that this capacitor has just burst open. So we need to replace that. Let's see what we've got in the drawer. I don't think it's going to be a critical value. I've just noticed this wire that connects to this turn wheel directional switch as the wire's fallen off it, so we'll just put that back on. I would have expected if that if this capacitor's blown out, it's probably really quite a good reason to swap out all the others. And if I do manage to get some life back into this piece of equipment, I will do that. I will change them out. Okay, let's try putting some power on this. Let's see if it's any more broken than it was when I was given it. Okay, effectively it's doing just the same thing it did when it was given to me, and that we're getting well, it's actually probably, unfortunately, doing a bit less. We're getting oh no, actually I think it's doing just the same. We're getting basically a 5, if I can wake that up again and get that, sorry. It's effectively just doing what it did before. I've just been poking around with this for a little bit longer, really just going through it with a flux pen. I found a myriad of dry joints all over everything. Probably just a combination of age, and I think maybe a few bad solder joints in the first place. But as I was going round it, I've come back to these tracks that we saw earlier. They'd been damaged by the leaking batteries. Well, I've had a close look at these now, and I don't know if it will show up on camera. Let's see if it will come in. Will that focus? Okay, you can see maybe in the middle of the board now, middle of the camera shot, there is actually some tracks which have been completely eaten away. The problem I seem to be having is the display is stuck. I've been trying to trace it through the drivers onto the display, and yeah, I'm getting I'm getting some of the correct strobe lines, etc. Or rather, all the strobe lines are working. I'm just not sure about the actual data lines, but I'm pretty sure that some of these resistors things down here do have something to do with that strobing, even though they are the opposite side of the board. So what I think I need to do is I need to have a look at them and maybe put some patches back in, put some link wires in, see if I can get those tracks that have been eaten away, see if I can get them joined back up again. I don't know if it's going to be possible actually. As I say, this board is in a pretty bad way, but we'll I guess we'll have a go. There's nothing to lose. The next thing that I'm going to take a look at is this display unit. Whenever it powers up, it appears to display multiples of what is looking like almost like a 5 symbol. And this uses a multiplex display for these 7 segments, which we'll just take a look at next. So we've got this display that has 5 elements, each one consisting of a 7 segment display plus decimal point indicator. And the problem that we appear to have is whenever the unit powers up, we get this random pattern occurring across all the 7 segment displays. So here's our kind of random pattern of segments F, C and D, and whenever I actually just turn the unit on, it always comes up with that. But if I select maybe a number, that's something which would, for example, light up most of the segments correctly, which is a number 8. Try that again, sorry, you're not in camera, are you? So if I just select to put, say, a number 8 on, we can see that quite a few of the segments are now appearing to work normally. I think that maybe I'm pressing no. Alright, okay. I was pressing number 9. Okay, I'll press 8 now. So we can see that we're certainly getting some 8 symbols on there. But when the display, when the display tries to turn off the number 8, we still get left with this bizarre pattern. So let's just come back and have a look at the circuit diagram. So the display has 1, 2, 3, 4, 5 digits with a couple of decimal stops, and it's a fairly typical 7 segment display arrangement, this, what they would call a multiplex display. So each of the segments labelled A to G on here is controlled by one of these transistors, and I don't know if that'll come out. For example, this transistor is controlling A segment, which is that one. We'll just go through them actually. Transistor 25 is controlling the B segment. Transistor 26 is controlling the C segment. Transistor 27 is controlling the D segment. Transistor 28 is controlling the E segment there. And transistor 29 is doing the F. And transistor 30 is doing the G. Now, so what these transistors can do is they can switch on any of these segments to make the pattern that we want to see. So, for example, if we're displaying a number 8, all the segments would be turned on. So each of these transistors, 24 to 30, would all be switched on as well, because they're actually switching the power to the LEDs that make up the 7 segment display. Now, there's something else going on here though, is obviously there's more than one display used, and this is where this term multiplexing comes in. We have what they call strobe lines at the top of the circuit here, and what they allow the I guess the microprocessor to do, the thing that's doing the controlling, it will just select one of these segments at a time. So the fault with the display is that it appears that segments F, C and D are switched on constantly. What I'm going to do is the first kind of test to find out what's happening here is I just want to have a look at the at what's actually going from the microprocessor to the control board. I don't know if this will come out on camera. Each of the segments of the 7-segment display, it's hooked up to the processor using, well, it's got pins 1, 2, 3, 4, 5, 6 and 7. And what I'd like to do is just make sure that each of those pins is effectively going high when I want to turn on the segments, and it's going low when I don't want the segment to turn on. What I'm checking for is that this the 7-segment display, the 7-segment drive coming from the microprocessor is correct, and for example it's not one of these input pins here which is it's not one of these output pins which is shorted out, for example, to 5 volts, which would cause the display to constantly illuminate. Now I'm pretty sure it isn't that, and I'm just basing that diagnosis on the fact that I've already seen a lot of corrosion on these transistors and resistors here, so it's much more than likely that it's one of these transistors that is corroded or damaged. That's likely what the problem is, but before I just jump into changing them out, I just want to check that we're getting the right drive signal from the microprocessor. So let's have a look at that. And I've just been having a look at the resistance between the collectors and the emitters of the transistors. Now typically it looks like all the segments which aren't lit, the ones that appear to be working correctly, that resistance value is around the 4 megohms. But strangely enough, the segments which are lighting up erroneously, again, which is F, C and Z, they're controlled by transistors 26, 27 and 29. Now, when we actually have a look at the resistance between the emitters on there, for example, transistor 26 is showing 6K, transistor 27 is showing 3K, and transistor 29 is showing 3.2K as well. So we're getting kind of 7 orders of magnitude really between what I think is a good segment resistor for each of the transistors and what a bad one is. So I'm really suspecting now it's those transistors are either short, that's most likely, or just due to the corrosion in that area. And I can see that there is a lot of corrosion around that side of the board, that maybe there's some corrosion under them or around them which is giving this misleading reading. So I think the next job is to remove those transistors and see if we can well, the first thing that will happen is when we remove those transistors we should find that the troublesome segments don't illuminate anymore, and we can, once we've removed them, we can put them on a transistor tester and see whether they still work or not. Okay, I'm going to have a go at removing this this first transistor, which is going to be what's TR27, and that's the transistor that's let's just check. TR27 is what's actually responsible for energizing the D section, which is the bottom bar on the 7-segment display, and this is one of the transistors that's got an emitter collector resistance of around 6K. As I said, all the others are an order magnitude different to that. So let's have a go. I'm not massively hopeful because my success ratio using this hot air station stands to be around pretty much 0 at the moment, but let's have a go. Okay, I've got it off. Actually, that seemed to come off better than I thought it did. Much easier than I thought it did. So I think maybe I might have been a little bit too aggressive on the heat and the temperature there. I almost just blew it off, so I think I might turn the temperature down a little bit and the airflow, because it's turned quite high at the moment. So I've turned the airflow down quite a bit there, and the temperature's indicating 233 on here, but I've got no idea whether or not that's accurate or not. So that's the first one off. Which was the next transistor? The next one was we've just took off 27, so the next one is 26 and 29. We'll pop all these off and then we'll just we'll give them a measure, see what that comes up as. Well, I've just realised that you were looking at entirely the wrong bit of the circuit there. Again, that came off quite easily. I think I might be pulling these a little bit hard. I think I need to be a bit more gentle with them. And the final one is transistor 29. Let's just double check that on the overlay, find out which one that is. Okay, I think transistor 29, there's two here, and I think that it is that one. Okay, that's pulled all them off. I wonder if we can try them on the transistor analyzer and see whether or not they're any good or if they're dead. Let's give that a go. Right, we've soldered our bodge wires onto these transistors, and let's just give them a test and see if they are actually still working as transistors. Okay, so it does, yeah, it has detected it's a transistor, but it's got an HFE of 9, which seems pretty pitiful. Now those values do sound low, very low. However, I don't know what type of transistor it is, but given that I'm assuming it's some kind of small transistor, small signal transistor, I'd probably be expecting something around 100 maybe, but I'm sure it depends. Just looking around on the bench now to see if it, in the service data, if it tells me what this transistor actually is. Maybe I'll have to see if I can look it up on the internet. I don't think there's really any point in testing them all. What I suspect the best thing to do now is just try and substitute them for something else, so let's see if we can find something appropriate. Okay, I'm just going to try and solder in the last of these surface mount transistors. I found, I just had a look for the junk box and I don't seem to have a lot of these surface mount transistors. My best guess is that these are 547s, which are NPN transistors with an HFE of around 110. Just having a look through the junk box, I've managed to find BC817s, which are just described as a general purpose transistor, and they have a similar HFE, similar characteristics, and these are probably about the best I can find in the junk box. And I'm just going to try and get one of these back on. I'm probably not really going to be able to keep you in shot while I'm doing this. It's I'm kind of fighting with magnifying glasses and things like that. I have got a microscope, but I've not bothered to get that out because I've just got things in the way. So let's just see if I can get this transistor on. These are fairly small devices. Okay, that's on. Does it work? So first thing I'm hoping is when I put a power supply on, all those um, all those segments that were switching on erroneously last time, let's hope that they don't come on now. Always a little bit dubious connecting power supplies up. Okay, well, nothing's lit up, which at the moment is a good sign. Right, I think most of the segments came up. I don't remember one of the videos I did a few weeks ago. I was using this logic pulse. Well, I'm just doing that at the moment. I'm just putting a signal onto the base of each of these switching transistors, and I was just going around there to see if I could get each of the segments to light up. And I'm afraid I wasn't really keeping much of a count there of what I was, of which segments were lighting up. So there's the middle one, top left, bottom right, top right. Right, did we see the very top light up? I've got a feeling we didn't. There we go, top. Alright, I think that might be a success. Right, I've got the actual drive from the microprocessor disconnected at the moment, so let's just wire that up. I don't know if you can see that, I'll just say that. I've got this cable disconnected. I'm just going to solder that back in and then we'll give it another test. For no particular reason, I've started when I'm making connections and old things like this. I've just found that sometimes just putting a little bit of extra flux in just helps. Some of these connections are probably quite dirty and oxidised underneath, and just a little bit more of this liquid flux, it just helps. And the other thing I think it helps with, it makes the joint a little bit quicker. So the last thing you want to do is be fiddling around trying to make a joint, putting lots of heat in and risk burning a pad off. So I just find that putting a little bit of liquid flux on, it just maximises my chances of just getting it right first time. So I'm just going to tack a couple at each edge to hold all these pins in, and then we'll just go around and solder them one by one. So when I switch it on, I'm not getting the corruption on the display now. I am not getting all those segments lit that shouldn't be. I can only really get the first and second digits lit at the moment, but I'm not exactly sure what this should do anyway. So given that I don't know how it works or how it's meant to work, I don't know whether this is right or wrong, but we're not getting the corruption, so I think that must be a step in the right direction. Okay, we seem to have got the display working or partially working. And I think the next thing to do is just to see if this thing is transmitting and receiving. Now, of course, it's infrared, so there is an infrared transmitting LED on here, but of course I can't see it. What I was hoping is if I held it in front of a camera, that I would actually be able to see it on the camera, because even though the human eye isn't particularly sensitive to infrared, cameras tend to be. But I've tried that and I can't actually see anything coming out of it. So what I'm doing instead is I've hooked up the scope to it onto the back of the infrared LED transmitter, and as I jog the volume control backwards and forwards, I'm just observing the data. So I'll just turn you around so we can have a look on the scope. Right, okay, I'm jogging this volume control backwards and forwards, and what you can see there is the scope showing what's appearing across the infrared transmitting diode. So I'll just take a single shot of that, and let's just zoom in on one of those waveforms. And yeah, basically that's a transmitted request for information. I don't know what that means, I don't know how to decode it, but that looks as though it's doing something. It's at least transmitting something. What that means I have no idea, but it is transmitting something. So there's two sides to this. There's a left and a right channel, so I'll just plug the other channel in and we'll see if the scope's outputting. We'll just plug the other transmitter board in. The one I've got plugged in at the moment is the left side board, so we'll just try plugging in the right side board and see if that appears to work as well. Okay, that one appears to be working as well. We can just see the data flashing up on the yellow trace on the scope. So it certainly seems to be transmitting. Just while I was examining this board, I could see that this is the one that I washed earlier and stripped down, and I don't know if you have focus on there, but some of these connections are quite corroded. So what I think we'll do is, just as a precaution, we'll just solder them up. I can actually see across the receiver diode here that the tracks are actually moving. It's actually in the process of breaking off the board, so that needs some repair on it, and just some little link wires putting in. So we'll do that next. Okay, I've just patched up the board there, just wired in some couple of little bodge wires, one from there to there and one from here to here, just a short link, because it's actually ripped the pads off already. So what I'll probably try and do is just put some reinforcing on this side, put a little bit of epoxy, or actually, being lazy, I can't be bothered to wait for epoxy. I'll probably just squirt some super glue down there, or maybe some hot melt glue. Just noticed I was just trying to solder in this LED a little bit better, and I just put the soldering iron on it and it actually fell off, because I've just noticed that the terminals for this LED, they don't actually go through the board, they just sat on pads. To me that just seems a little bit bodgy, it's asking for trouble. So I think I'm just going to take these LEDs off and have another go at soldering them back on again, because with some fresh solder, because there has been some corrosion around there, I can see it. This is one of those transceiver boards, and I was just putting it back together now, doing the final assembly, and I accidentally just touched the LED, and unfortunately it's the LED has just broken off from the board. This is the board that was already quite corroded, and you can see I had to put some bodge wires on it earlier, but I just touched this LED and it's broken off. But I can see the tracks very easily where it should have gone to. So again, what I think I'm going to have to do is I'm just going to have to solder on some bodge wires, and I'll probably put the LED in with some super glue, and just to hold it finally in place, and maybe even put some hot melt glue around it. So we'll have a go at repairing that. I think it's probably worth just gluing this LED in before I do any more, because if not it's just going to fall out and keep tugging at the wires. So I've got a little bit of super glue here, and we'll glue this in and see if this helps. I'm actually also wondering if I can just put a bit of super glue where the pads originally were, and maybe just glue them back on. I'm not going to use the pads, but it might just give it a bit of just give it a bit more mechanical strength, although maybe it'll burn off with heat from the soldering iron, you can tell. Right, and am I going to end up with an infrared LED glued to my finger? There's the question. It's pretty likely. Okay, let's see if that's going to stay. Bodge wires. That didn't help, the pad just came off when I touched the soldering iron to it. That's annoying. Let's just tin that wire. I don't think this has been one of my better videos. It's all been a little bit rushed, and yeah, maybe I don't know if I'll even put this up. The main idea of this wasn't really doing this as a repair video. I actually just wanted to get this piece of equipment repaired, but it seemed like a good opportunity to have a go at filming something, so that's what I've done. That looks like it's got it, and just going to put another little dab of super glue onto these bond wires again, just to give it maybe a little bit more mechanical strength. While we're at it, I might as well put a little bit of glue onto this other one. Now unfortunately I only have this master control unit. I don't actually have the hi-fi system that goes with it. So I've really tested everything I can. The display appears to be working now and all the push buttons, so that's a step forward. But because I only have the controller and not the hi-fi system, one thing that it isn't going to be particularly easy for me to test is the infrared transceiver on it. Now what I was hoping is that this camera was going to be sensitive to the infrared, because some cameras are, but just a minute ago I did actually try holding this LED, this control board, up to the camera and trying to activate the unit, and I was hoping that you would be able to see this flashing on the camera, but it doesn't appear to be sensitive because this camera will have an IR filter on it. So the way that I'm actually going to test it, as you can see here, I've got an oscilloscope hooked up, and the oscilloscope is hooked up to the final stage of the infrared receiver circuit, just before it actually goes into the microprocessor. So we've got the oscilloscope set up to monitor that probe. So if I can just put the oscilloscope in shot, you can see the data, which basically is being transmitted off the roof, off the ceiling of my little workshop, and it's coming back down, and it's entering into the receive circuit, and I'm displaying that on the oscilloscope. So that's good. So that test there is showing me that the transmitter side is working, and the receive side. And just as another confirmation of that, I've just got a control unit here, just from another piece of equipment, and what we can do is we can just interrupt the received waveform, and you can see we're getting a different pattern now. So I'm going to stop pressing this, and it should go back to the previous pattern, which it does. So you can see that the receiver's working, because I am able to interrupt it when I use this other remote control unit. Unfortunately, as I said, I don't have the hi-fi system to actually test. So I think I've done as much as I can with this now. Everything appears to work. Can I just show you that? Okay, the volume pot works now, and the display isn't putting that garbage up that it was previously, and I only seem to get 2 of the digits working, but I don't know if this is normal. Maybe it only goes up to 99, but it's certainly doing more than it did before. Of course it does keep flashing up no contact, because I assume that's because it's expecting to get some response from the hi-fi, which it's not getting. So I'm going to consider this fixed, and what I'm going to do is I'm going to take it back to work next week and give it back to Richard, the chap who gave it to me, and he'll have to test it on his hi-fi system, and I'll let you know how I get on. Thanks very much. Bye bye.